Thank you for workshop organizer to invite me for this presentation. My name is Hongbin. I'm Director of Product Marketing at LONGi Solar. Today, I'm going to share our work on how we do to ensure solid PERC module reliability, especially those made with a gallium-doped mono wafers. Before we dive into technical details, let me give a brief intro to our company. LONGi is becoming #1 module manufacturer by shipment in 2020. Since LONGi expanded into cell and module business at the end of 2014, it has steadily improved its shipment ranking over the last few years. In 2020, LONGi shipped over 20 GW mono PERC modules globally. LONGi is also the most bankable module brand, achieving the only AAA rating among all PV module manufacturers in PV Tech bankability rating for the last 4 quarters. LONGi always consider ourselves a technology company by investing 5 to 7% of our revenue into R&D. Consistent investment in R&D enables LONGi to develop products with the leading performance but a lower cost, which in turn enables LONGi to achieve strong financial performance. LONGi has been leading the industry with the technological innovations throughout the years. We have been persistently working on improving mono wafer manufacturing productivity and reduce mono wafer costs since 2006. At the end of 2014, LONGi expanded from pure wafer manufacturer to cell and module business. Since then, we have helped industry shift from multi-dominant to mono-dominant in a few years. LONGi is one of the first companies doing PERC in 2016, and we introduced bifacial PERC into market in 2017. Since then, more and more customers have realized the value of bifacial PERC technology and adopted it in their utility project. Significantly higher energy yield with the bifacial PERC technology is an effective way to help our customers to realize lower LCOE. In 2019, we introduced M6 166mm wafer standard into the market and help our customers to reduce BOS costs quickly with the larger size modules. M6 has quickly become the most popular wafer and module size in industry. It will likely take about 50% of market share this year in 2021. Last year in 2020, we also introduced M10 182mm wafer, an optimal size for design for a large-scale utility project, hoping to reduce BOS costs further. All these innovations are focusing on bringing better value for our customers by reducing their BOS cost, improving energy yield, and realizing lower LCOE. When we look at the LCOE equation, numerator is composed of all costs, including module costs, BOS costs, and other costs such as finance and O&M costs. Denominators is composed of energy yield. What is not obvious is that reliability from modules and other system components play an important role to ensure expected energy yield is realized in the field. Throughout the years, there are many innovative technologies are introduced onto module manufacturing to improve its performance, to reduce its cost. These innovations will help to achieve better performance and lower LCOE, but only if they are reliable. If the newly introduced materials or module designs are not reliable, customers may experience significant energy yield loss throughout project lifetime, defeating their purpose of reducing LCOE. We think reliability is a prerequisite for implementing any new technology into production. It is a prerequisite for achieving lower LCOE. At LONGi, we take a comprehensive approach on reliability. We start from module design and BOM material selection, moving through process optimization and module-level reliability testing, and then establish strict production quality control. Finally, module performance is validated through field performance data collection. Every step along the way, we keep module reliability as top priority and as prerequisite for implementation. We verify reliability performance before moving to next phase. Reliability takes highest priority. That is our mindset. For example, transparent backsheet is an innovative material for bifacial modules. It offers some advantages compared to glass: lighter weight, no change from conventional module process. But when we evaluate its property, we find out there are many compromises. Out of those, reliability is the most important one. We have not been able to identify a transparent backsheet to meet our internal reliability criteria for backsheet qualification. Thus, we have been sticking to glass-glass structure for all our bifacial PERC modules. Now, let's take a look at the degradation mechanisms on PERC modules. Conventional PERC cells show the poor LID performance and an inconsistent LE-TID behavior, reducing its customer value. Before we introduced the PERC into market, we had to optimize the PERC cell process and control LID and LE-TID performance. That is why PERC cell can be adopted widely, becoming dominant technology in recent years. More recently, gallium doping technology is introduced. Gallium doping enables better LID and LE-TID control on PERC cells. Gallium doping eliminates boron-oxygen defects and helps to reduce LID. Gallium doping also makes it easier to manage LE-TID on PERC cells. Using gallium doping to make p-type wafers, there are some technical challenges, such as large segregation coefficient with the gallium. LONGi team has to work around to improve doping profile in ingot and reduce wafer manufacturing costs, delivering gallium-doped wafers at a competitive pricing. On the cell side, our team can actually achieve better cell efficiency with gallium-doped wafers. At the module level, consistent LID performance has been demonstrated on mono PERC and bifacial PERC modules by multiple third-party labs. Solid LE-TID performance has also been demonstrated on mono PERC and bifacial PERC modules by multiple third-party labs. On our mono PERC and bifacial PERC modules, extended reliability testing has also shown consistent low degradation. Reliable materials, in combination with optimized cell and module processes, ensure solid extended reliability testing results. Solid reliability, performance, and quality on our PERC modules have also been recognized by third-party labs. ITC PV Module Index recognized LONGi as one of 3 overall high achievers. LONGi is the only manufacturer performing well in all 8 indicators in the IETC's PV Module Index Report 2020. Our bifacial PERC modules also demonstrated better energy yield than other bifacial modules at the PVEL test site. Backside energy yield on our bifacial PERC modules can be as high as almost 2% higher than other bifacial modules on glass and then more than 3% on white. This again demonstrated that not all bifacial modules are made the same. They do not perform the same. Module design, material selection, and the production quality control all play important roles to ensure consistent and reliable module performance in the field. Another example comes from PV Magazine test sites. Our bifacial PERC and mono PERC modules have demonstrated better energy yield than other modules in the market. Here's another example how we approach reliability when we design modules. There are 2 main camps of large format modules. One using 182mm wafers, and one using two 10mm wafers. Using 182mm wafers, module IC is about 13.8 amp, and then using two 10mm wafers, module IC is about 18.3 amp. Taking into consideration of safety requirement, we decided to design J-box with a 25 amp rating, leaving about 10% margin, while the two 10mm modules using 30 amp J-box, leaving almost no margin. Besides, 30 amp J-box has to use two diodes in parallel. Uneven current split of two parallel diodes will also increase the failure risk. Another reliability risk with the two 10mm modules is on mechanical loading. Increasing module width from 1133mm for 182 module to 1303mm for 210 module. The deformation will increase 40%. The frame stress will increase 30 to 70%. These factors will increase reliability risk for two 10mm modules significantly. In summary, module reliability is a prerequisite for implementing any new technology into production. It is a prerequisite for achieving lower LCOE. Comprehensive approach is taken at LONGi to ensure module reliability and performance. From module design, material selection, process optimization, to production quality control and product reliability testing and field performance validation. All aspects have to be considered and evaluated to ensure reliable module performance. Gallium doping enables better LID and then LETID control on PERC cells. Better cell efficiency, consistent LID, and LETID performance have been demonstrated using gallium-doped wafers. LONGi bifacial PERC modules have demonstrated consistent performance in extended reliability testing by third-party labs. Not all bifacial PERC modules are made the same. LONGi bifacial PERC modules demonstrated better energy yield compared to others at the third-party test site. Thank you for your attention. Feel free to reach out to me if there is any question.